Okay, in this video, we're going to pick up where the last video left off because we were getting a little too long. So we're going to call this part two of all these items that were supposed to be discussed. But we already discussed weighted graph and traveling salesman problem. So we're going to actually talk about the nearest neighbor algorithm and the heuristic method. Okay, so let's go ahead and get started. This is where we left off yesterday, where we had our problem, our little map, so to speak, and then we had our tree diagram that we created from that. Now remember, your tree diagram will always show you all the possible routes that you could have taken started with St. Louis to get back to St. Louis, okay? Now from here we can actually ask a couple of questions, meaning if I was to say what is your shortest route, you would say, oh, that's 2530. And remember that when you make these this tree diagram is going to show all of your routes more than once. So you're going to have duplicate answers. But let's talk about the nearest neighbor. Okay, let's go back and let's talk about the nearest neighbor, which is right there. Now, the nearest neighbor has a more specific way to uh, figure out a route versus making this tree diagram. Okay, so with the nearest neighbor, you always have a starting point, and our starting point will be St. Louis. Now, the question you have to ask for nearest neighbor is, who is your nearest neighbor from St. Louis? Well, it could be Minneapolis, which is 550, New Orleans, which is 670, or Chicago, which is 270. Well, 270 is the lowest number, so we're going to go to Chicago. Now, from Chicago, once again, you figure out who is your nearest neighbor. Is it Minneapolis with 400 or New Orleans with 910? Now, some of y'all might say, hey, it's actually St. Louis was 270, but we've already been to St. Louis when we got to go somewhere else. So it's going to be Minneapolis. So from Minneapolis, where is your nearest neighbor? But as you move through your graph here, you cannot go back to the starting point until you've completed your entire circuit. So it kind of limits you to where you can go. So with Minneapolis, I have to go to New Orleans because that's my only option left, which is right there. And then from New Orleans, I'm just going to complete my circuit, and there you go. So that is my nearest neighbor. So if I was to write down how I went, I started with St. Louis, and then I went to Chicago, and then I went to Minneapolis, then I went to New Orleans, and then lastly I finished up with St. Louis. So if I was to add all that information up, I would get 2,600 miles. Okay, let's try another problem. Here we have this problem right here, and it's a little small, so let's see if I can zoom in on this just to make it a little easier on the eyes. Let's see. There we go. All right, so we're going to do a nearest neighbor problem, even though it says traveling salesman problem, okay? Because usually you will add, you will do a nearest neighbor on top of a traveling salesman problem just so you can compare your answers here. But let's um, let's do nearest neighbor. Now each problem will always give you a starting point. All right, so we're just going to say, let's just say A is our starting point. Okay, so from A, let's go ahead and see where we can go. Now remember, if you want to go ahead and work ahead, feel free to pause the video and just go ahead and work through this problem, and then we'll check our answers after we finish. All right, so starting with A, the slowest, or not the slowest, but the uh, place that is Uh, closest to A, let's see, it would be E, I believe, 75. Now from E, I'm looking, and it looks like D would be the closest route here. Now I'm looking again for what's closest. C is at 100, but D is at 75. Maybe hard to read this, but it's D is it, or B, I'm sorry, B is it. Now from here, remember, once you start moving through the graph, you're dealing with problems where you're running out of options. So from here, when you get to like B, you have to go to C. There's no, I mean, if you go to A, then you don't complete the circuit correctly. So you have to go to B, and then from there you go all the way to C to complete your circuit. So there you go. So if I asked you, okay, give me the route in which you took, you would say, well, starting with A, I then went to E, then went to D, and then B, and then C, and then back to A. And that would give me a total of 375. Now, since it's traveling salesman, we'll just say 375 miles. Okay, pretty simple. Now, the last thing that we're going to talk about is the heuristic method, and that's the way I'm pronouncing it. May be um, a better way to do it, but that's the way I'm going to pronounce it in this video and from for the rest of this semester. The heuristic method, basically, the way that I read into it is that it's a method that produces a quick and reasonable closed optional solution. Now, the way that I'm going to use this in this chapter is I'm going to look at a problem that we started off with the traveling salesman. So this right here is nearest neighbor, and of course this right here is all of your routes. Now you already know that your smallest route is 200 or 2,530 miles, like so. But under traveling salesman, you're actually driving further. So I would say, is this the best option for you to use or to do? And you would say, no, it's not because of the fact that you're driving 70 more miles. So that's how I would use the heuristic method in this unit. So if you have any questions, let me know. Thank you for watching.